Math 3, Unit 11, Section 2. Today we are going to start talking about logarithms. If you recall back in Section 1, we talked about what power of 5 gives us the answer of 25, and that is 2. This what power is the same thing as a logarithm. So a log base 5 of 25 is 2. Right here, you can go back and forth in between exponential functions, okay? So there's exponential and logarithmic functions. This is a log, okay? And so you'll notice here between exponents and logarithms is that with exponents, the b is your base here, and the base, it goes log where the little b is. That's the same thing where the base is. Here, this p is the exponent, and this is where the answer is to your log equation. And then n is the answer. So for instance, here, this is saying log base 5 of 125, or what power of 5 will give me the answer of 125, and that is 3. If we were to change this to exponential form, instead of having log base 5, you just have base 5, or 5 to the third power equals 125. And so in this case, for these equations, the base is 5 and our exponent is 3, or your exponent or power. So this first part here, I want to make sure you understand what's going on, and so all I want us to do is rewrite this from log form into exponential form. And so if we start with this first example here, log base 5 root 5 equals 1/2. They've given us the whole answer because 5 to the 1/2 power equals root 5. And so that's it. We are just writing the exponential form. 5 to the 1/2 power equals root 5. So I'm going to give you just, about 15 seconds here. Go ahead and rewrite this one in exponential form. Okay, so you should have written again here, we have log base 3 of 1/9 equals -2. In exponential form, that is saying that 3 to the -2nd power gives us the answer of 1/9. We can also change from exponential form to logarithmic form. And so here, this is the exponent form, and we want to change this into log form. So instead of saying 2 to the 5th power, remember we would say what power? And so this would be, the what power is log. Log base 2 of 32 equals 5. 2 to what power is 32? 2 to the 5th power is 32. And so this is the log form. So the base that we have in our exponent goes to the base of the log. The answer part goes next to the log, and then the exponent is where the answer is for logs. So same thing on here, we would write log base 10 of 0.001 equals -3. What you're going to find out is that the majority of logs are base 10. And so we do not have to write base 10 when it is a base 10. And so anytime you just see log and then 0.001 equals -3, if they don't give you the base, it's automatically base 10. So both of these answers are correct, but you won't see the 10 written when it's base 10. So really this one here in purple is more accurate. Okay, so this next part, we would like you to evaluate the following logarithms. If needed, write an equivalent exponential equation. So again, remember this is saying 6 to what power equals 216. And so if you know the answer, wonderful. If you don't know the answer, you basically just need to figure out, well, what power of 6 makes 216? And so you could play around with it in your calculator. You know that 6 to the second power is 36, and so I would try 6 to the third, and if you try 6 to the third, you will find out that it does equal 216. So my answer here, I'm putting x equals 3, but really it's not x equals 3. My answer is just 3. This answer to this log equation is 3. Okay, same thing on example 2. Log base 4 of 256 equals what? Or what power, 4 to what power equals 256? So again, you can go through your calculator and figure out 4 to what power is 256, and the answer you should end up getting is 4. Here, log base 5 of 1. So again, 5 to what power equals 1? And so in order to get this to equal 1, it has to be 0. Okay, so 5 to the 0 power equals 1. Example 4, log base 2 of 1/4, or 2 to what power equals 1/4. When you look at this one, hopefully you recognize 4 can be written as a base 2. Okay, 4 is the same thing as 2 squared. And then we talked about this back in section 1, but in order to make it so that the 2's are at the same level, we would want to bring this up in the fraction, and when you do that, it changes to a negative. So we can always go back and forth, changing things from negatives to positives. And so we get 2 to the x equals, when we bring this 2 to the second up, it becomes 2 to the negative 2, which means that my answer for this equation is x equals -2, or just -2. So log base 2 of 1/4 is equal to -2. Example 5. Same thing here, 7 to what power equals the cubed root of 7? How can we rewrite that in exponential form? So hopefully you remember, again, we talked about this again in lesson 1 here, but 7, this is really 7 to the first power. And so we can rewrite this as 7 to the 1/3 power, because the 1 goes on top and the 3 is in the root. And then I have 7 to the x, so this means that the power is 1/3. Notice on example 6 here, it doesn't give us a base. So back like in example 2 up here, I had said if it doesn't state what the base is 10. And so on this one, notice it's not stating the base, so that means the base is actually 10. And so we're saying 10 to what power equals 10 to the 5th? Hopefully that answer is pretty easy for you, and that answer is 5. Okay, we're going to go ahead and move on here. So example 7, you'll notice it doesn't say a log now. This is representing an L and an N. And that actually represents something called a natural log. Now, why they do ln instead of nl, I am not sure, but this is just another form of a log function, and it's ln is just a natural log. Natural log is always in base e. And if you have a calculator near you, you can look on there and you'll actually see the function of e and raising e to a certain power. E is similar to pi. It's an irrational number, and so it's there in your calculator. So when you see natural log here and it says root e, this base, they never tell you the base or won't state the base on natural logs because it's always base e. Just like with logs, if it doesn't say it, it's base 10. Well, natural logs, it can't be anything except for base e. And so on this one, it's saying e to what power gives you root e as an answer. We can write that out. E to what power equals root e. So hopefully, again, you realize that square root functions, we can write those as exponents. And right now this e is e to the first power, and this is a square root. And so to rewrite this in exponential form, this would be e to the 1/2. which means the natural log of root e equals 1/2. So the answer for example 7 is 1/2. Now I'm going through all this process here, but if when you're doing your homework, you know the answer and you don't have to show all this work, I'm okay with that. I just want to make sure you understand this process. So again here, it's natural log, and we know that natural log is always base e. It will never state that it's base e because we know that all of them are base e. So on this one, it's saying the natural log of 1, or what power, so e to what power equals 1 over e to the third. So these are not at the same level where we could say that x equals this, because this e is in the denominator and this e is not in a denominator. And so in order to take this e to the third and bring it up, what do? Hopefully you said we're going to make that a negative. So e to the x equals e to the negative third, which means that my answer here is -3. There will be a time when we might get a question and there isn't an exact answer, but we can approximate. And so we're going to talk about approximating logs here for just a minute. And so if you see here, it says if we write log base 210 in exponential form, we get 2 to the x equals 10. So right here it's saying 2 to what power equals 10. And there is not a number that would give you the exact value of 10, because we know, if you notice here, 2 to the third power is 8 and 2 to the fourth power is 16. And so the value of 10 is going to be some number between 3 and 4. And so therefore this answer would just be between 3 and 4. That would be the value, okay? X would have to be between 3 and 4. So here, state which two consecutive integers the exponent lies between. If we write this in exponential form, this is stating 3 to what power equals 25. So we know that 3, we can't have a power here that totally equals 25. So we're going to write down the two numbers that it's in between. We know that 3 to the second power is 9. We know that 3 to the third power is 27. Right here you can see that we've gone past where the 25 mark is. So that means that my answer has to be between 2 and 3. Okay, on example 2 here, this is stating 7 to what power equals 9. 7 to the first power is 7. 7 to the second power is 49, which means that my answer has to be between 1 and 2. Okay, I'm going to give you just about 30 seconds, maybe a little less, to try to solve example 3 on your own. Okay, so this one you're dealing with a little bit of a bigger number, but I'm sure you guys were able to figure out. Again, we have 3 to what power equals 200. So over here we already went to 3 to the third. So I'm going to go ahead and write that again. 3 to the third is 27. 3 to the fourth power is 81. And 3 to the fifth power is 243. So now that I've been able to go past the 200 mark, I can see that my answer here is going to be somewhere between 4 and 5. Okay, last part, we want you to be able to find the y-intercept for the following functions. So far, we actually have not graphed log functions, and we're going to get to that in lesson 4. But for this case, if we wanted to find the y-intercept, do you remember what we do in order to find a y-intercept? So if I just like on a graph wanted to find the y-intercept, it is always up the place where x equals 0. So if x equals 0, we find our y-intercept. And that's exactly what we're going to do for these examples. We are going to plug in 0 for x. Okay, and then we're going to go ahead and try to solve after we do that. If we look at example 1, I'm going to plug in 0 for x. So I have, and we're going to solve for y. So y equals log base 3 of 0 plus 9, and then minus 1. What is 0 plus 9? It's a tough one, I know, but that's 9. So we get log base 3 of 9. So 3 to what power gives me 9? Hopefully you said 2. Okay, and so then all we're going to go is 2 minus 1, which equals 1. So therefore, my y-intercept on here is 1. You could also write it as an ordered pair if you wanted to, which is 0, 1. The x value is 0, the y value is 1. Okay, so I'm going to give you a little bit of time here to go ahead and figure out the answer to example 2. Okay, just in case you're stuck, I'm going to go ahead and start going through this. So again, we're going to plug in 0 for x. We have y equals log of 0 plus 1, and then plus 3. 0 plus 1 is 1. So I have log of 1. Now notice again here, there's no base. If there's no base, we know it's actually 10. Okay? So this is saying 10 to what power equals 1? And it wouldn't actually matter what your base is here, because whatever it is, the only thing that will give you the answer 1 is a 0 power. So 10 to the 0 power equals 1. If this had been a 5, 5 to the 0 power equals 1. So anytime you have log of 1, no matter what the base is, the answer there is always going to be 0. So we have 0 plus 3, and 0 plus 3 equals 3. This means that my y-intercept for this problem is 3. Or we could think of this as 0, 3 as the ordered pair on the graph.